FX Medicine is your gateway to news, resources and information on the safe, evidence-based approach to practicing complementary and integrative medicine. Visit fxmedicine.com.au to sign up for e-news and stay up to date with the latest research, podcasts and industry information. This is FX Medicine. I'm Andrew Whitfield Cook. Joining us on the line today is Vanita Dahia, who's an integrative medicine clinical consultant, pharmacist, naturopath and clinical nutritionist. She's a board-certified fellow in anti-aging and regenerative medicine, providing clinical training programs and educational initiatives to doctors and allied health practitioners, a functional pathology clinical consultant, health services manager and international speaker. Vanita is a medical authority, an extraordinary mentor for her peers and patients alike. She's more than 30 years' experience in compounding pharmacy, functional pathology, herbal, Ayurvedic and integrative medicine. Vanita received her training in anti-aging medicine through association and membership with the American Academy of Anti-Aging Medicine, that's A4M and A5M. Vanita is also the author of Alchemy of the Mind and Alchemy of Amino Acids, and it's the amino acid part we'll be discussing today. Welcome back to FX Medicine, Vanita. How are you?
Thank you very much, Andrew. Very well, thank you.
So, look, I guess we need to go back for a review. Let's call it a review. It might seem oversimplistic, but amino acids, what are they?
Amino acids are, as we all know, are the building blocks of protein. And protein, like carbs and fats, are part of our diet. Now, the word protein is actually derived from a Greek word meaning first, protos, meaning first, which is really designates its prominence in life. Amino acids are, as we said, building blocks. They're components of our growth hormone. They're building blocks of genetics. They're building blocks of they're involved in every metabolic pathway in the body. They manufacture hormones and neurotransmitters. They work synergistically with vitamins and minerals and trace elements to maintain the physiology. So amino acids, in essence, is as important as minerals for the sustenance of life. They work in a flow. They're constantly changing moment by moment by shifting the flow of your metabolic pathways in response to a whole bunch of physiological signals. So they're essential to life.
And indeed, enzymes are made up of amino acids, so there's this critical component of how things move, how things function in the body as well, isn't it?
That is correct. Even our genetics, when you're looking at our gene markers, they are in actual fact associated with amino acids. So they play a vital role.
Yeah, that's right. Okay, so now the next step, I guess, is classification. Now, this is something that bamboozles me a little bit. It's like there's not one simple classification. There's many different forms of classification. Can we go through a few of those?
Sure. Because amino acids are essential to our life, look, we know that they're part of our DNA. You know, we have the strands of DNA are consisting of adenosine and cytosine and guanine and thymine. And these bases make up what we call our genes. You know, our ancestral DNA is made up of these amino acids. Now, when we classify these amino acids, they can be classified predominantly on the basis of where they're found in the system. Like, are they needed by the body? Can we get them only from the diet? So amino acids that are derived from the diet and the body cannot make are called essential amino acids. And examples of that might be histidine, isoleucine, valine, methionine, phenylalanine. But then you can also get ones that are non-essential. These are actually made by the body. You don't need them from the diet, like stearine and proline. And then if the body's under a lot of stress, or there's a trauma, or there's infections, etc., then the body cannot make certain amino acids. They need to then be derived from the diet. And these are conditionally essential amino acids, such as glutamate, taurine, arginine. Now, that's based on where they come from in the diet. But they might also come from, they might have properties that are associated with their ability to be charged, or they might be polar, they may be basic, they may be acidic amino acids, or they might be alcoholic amino acids. For example, serine and threonine are alcoholic. Polar amino acids are aspartic acid and glycine. Then on the other hand, you can also have the classification based on its content, because amino acids are really an amino group and around a carbon group and a whole bunch of peptides. And the length of those peptides will give us an indication of what amino acid we're talking about. So the amino acids might be sulfur-containing. For example, in the methionine, they could be acid or they could be basic. Basic amino acids are like lysine and arginine. Then they can be also classified in accordance with action. So you might have amino acids that might be glucogenic or ketogenic, because these are metabolized to acetyl-CoA and acetoacetate through your Krebs cycle and citric acid cycle.
Yeah.
So there's a number of ways that one can classify, and it's important to actually understand the classification to be able to possibly glean the therapeutic function of these amino acids.
One thing that I found interesting about your book was that there's now a movement to really push for the conditionally essential status, if you like, or acceptance as a conditionally essential amino acid with the taurine in stress situations like trauma, burns, that sort of thing. Is that right?
That is correct. Some of the conditionally essential amino acids are being, the study of amino acids has expanded so much that we are now able to identify amazing therapeutic functions. As you said, taurine for specific conditions. Taurine is also being marketed quite heavily in the area of cardiovascular health as well. Yeah. So when we're combining amino acids, so important to compare and to understand and differentiate between amino acids found in these big bulking powders for weight loss or weight management or bodybuilding or muscle building versus the amino acids that are used therapeutically.
Yeah, indeed. I remember even decades ago, this was one particular baby formula was marketing their inclusion of taurine for infants. And they were one of the few at that stage. I think it's quite commonplace now. So it's just interesting to see the movement.
That's true. That's true. And it's also interesting to note that, for example, each amino acids are derived from a number of sources. They could come from soy or whey or fermented brown rice or hemp, or they may be derived from casein. It was really interesting. I had a patient once who had epileptic seizures that were not associated with, or seizures not associated with epilepsy. And following her neurotransmission pathways, we discovered that her glutamate levels were so high. So we managed to remove the glutamate toxic foods based on some of the work that Amy Yasko has done. The neuroprovoking glutamate toxic foods. And our foods are so heavily laced with glutamate toxicity. And so this patient was able to alleviate a lot of her episodes of seizures.
Wow.
But then subsequent to that, this patient went ahead and found, she's ready to hit the gym and started taking a protein powder and the seizures returned.
Right.
That's when I decided, I've got to now go and have a look at how the amino acids compare from one source to another. And I found that in comparison to pea and versus whey and soy and a few other sources, I found that the pea protein had the lowest level of glutamine or glutamate in comparison to all the others. So when you're using a protein source that is already made, one needs to actually identify that and then use it. It's particularly from a therapeutic perspective, use it with caution.
Yeah. Just as an aside on that, Amy Yasko's quite well known for, methylation issues, looking at genomic pathways, that sort of thing. Do you find that in these patients that assessing the genomic profile in these patients helps you with a nutritional prescription?
Absolutely, absolutely. Methylation cannot function without specific amino acids.
Yeah.
Methionine is needed as a precursor for SAMe. Serine is needed for the folate pathway. Cysteine, cystathine, all the sulfation pathways for the CBS pathway. We need the amino acids. And they don't work independently of each other. They work with vitamins and minerals, specific vitamins and minerals, to ensure that the whole methylation pathway works. So every physiological function, amino acids are used very, very effectively.
One other classification we haven't gone into yet, and that's the L and the D forms. And indeed, sometimes you'll see in supplements what's called a racemic mix, the LD or the DL, sorry. Mm-hmm. Can you comment on that? Obviously, the L form is the more natural in this case, is that right?
Yes. L form is actually the naturally occurring form of amino acids. These are basically isomers of a particular, in the way they rotate in the body, okay? So you will find your DNA strand is actually a rotational strand. They are rotating around each other. And the idea behind these isomers is that every time an amino acid occurs, generally most amino acids occur in both the isometric forms, both the dextrorotatory, which is D form, and the levorotatory, which is the anti-clockwise rotation, which is the L form of the amino acid. The only exception to those isomeric forms is glycine. Glycine only occurs in its L form. Now, and that's probably because of the possibility of the two different forms or stereoisomers around that central carbon atom. So the D configuration is often formed by fermentation, usually formed by bacteria, or it's formed synthetically. So an example of a D form would be D-serine. These are amino acids that are actually racemized or rearranged to form an L configuration. The work done by Dr. Walsh in a journal called Archive of Physiological Medicine Rehab, his work on D-L-phenylalanine. So this is a D
DLPA.
And an L isomer of phenylalanine.
Yeah.
Yeah. So that particular, he's found that something like D-L-phenylalanine has an amazing analgesic effect, whereas L-phenylalanine, we know L-phenylalanine is a precursor to dopamine as well as phenylethylamine. These are our neurotransmitters of catecholamines. But D-L-phenylalanine has the analgesic effect due to its stimulation or actually enzymatic degradation of the endorphins and enkephalins. So that's the reason why D-L-phenylalanine is used for pain management.
Yeah.
He's found that 250 milligrams of D-L-phenylalanine, taken 4 times a day, increased the pain response rate from 32 to 75%. So that's quite significant. I wouldn't say that would be a first line, but be a great adjunctive support for pain management, particularly today when there is a crisis situation with pain management and codeine restrictions and so forth.
Yeah, and particularly in Australia, we've seen codeine taken off the market since, February 2018?
That's correct, yes. It's good to know options available.
Well, that's right, because they're now also seeing a potential gabapentin abuse. It's just the next step along. It's like, what do we got now? So,
as well as the oxycodone abuse as well. So there's a next level. But it's not only affecting us in Australia, it's affecting the US as well. So it seems to be we need to consider and look at all the options available. And this is a great natural option.
The only issue I had clinically with using DLPA was the motivation of the patient to take it regularly throughout the day because it has a quick half-life. So you just had to really make sure that they were taking it quite regularly throughout the day, but very useful as an adjunct.
I mean, it can be used as an adjunct with some amazing herbs. There's some amazing herbs that we now found that have amazing analgesic effects, together with our spices, your ginger, turmeric, and so forth as well. So one has to consider the options available. What
about a potential toxicity, though, with the D form? I remember years ago there was this potential, and I would say not common, because there was the DL methionine was ubiquitous on the market then, but there was this rare issue of a toxicity with the D form of methionine. Is that right?
All amino acids, very importantly, all amino acids, when used in therapeutic doses, are really therapeutically beneficial. When used inappropriately, and if there may be a genetic predisposition, the patient may have phenylketonuria, for example, that is phenylalanine would be contraindicated, right?
Yeah.
So what we need to be aware of is, because of the fact that each of these medicaments, which we call amino acids, they have their own materia medica. They have their therapeutic action, their dosage, contraindication, side effect, and this is what is detailed in Alchemy of Amino Acids book. So it's really important to be aware that when we use amino acids therapeutically, there are side effects, there are contraindications. 90% of the time, they are safe. Now, in relation to answering your question regarding the D form versus the L form, there's a significant amount of studies showing toxicity, and so one needs to be aware of dosing as well. So we have detailed the appropriate therapeutic doses for each amino acid.
Let's go into some of the more obvious uses. I mean, the poster child is bodybuilding. What about other sports uses and, for instance, detox use by practitioners?
Okay, so the poster child is bodybuilding. So what does bodybuilding mean? Amino acids are involved in production of growth hormone. Our growth hormone, if you get a growth hormone injection, what you're getting is about 191 amino acids in an injection form, right? But the next poster child, which is really, really fashionable today, is particularly in the integrative medicine world, is the use of injection peptides. Have you heard of that?
Yeah, with the sports issues, yeah.
Yes. It's used in the sports arena, and it's literally it's an arbitrary measure. If we say there's 50 amino acids or less, we call them peptides, and if they're a chain of 50 amino acids and more, we call them proteins. But the study on peptides, Dr. Mollica, in his work on in the Pituitary Journal in 2010, on his work on effect of ghrelin, the peptide is called GHRP6. In 1995, he worked on this particular hormone. It's a ghrelin hormone that's shown to stimulate growth hormone. And growth hormone is predominantly amino acids. So the peptides now, originally used for bodybuilding and abused in that instance, has now been shown to be very, very beneficial in the area of inflammation in cancer patients and so forth. So when we're looking at the amino acids in the line of, let's say, detoxification, we require amino acids for all these pathways: glucuronidation, methylation, acetylation, sulfation. All of your detoxification pathways require specific amino acids. Taurine, glycine, methionine, threonine, these are the amino acids that are needed for phase 2 liver detoxification.
Yeah.
Another area, and we can expand on the area of gut function, because it's so amazing how you can stimulate digestion using histidine. You can support gut function through a number of ways. Perhaps looking into the use of specific amino acids for leaky gut, for detoxification. We can typically see we need taurine and glycine to stimulate bile acid production. Glycine and taurine actually inhibit the excitatory actions of the nervous system. So it allows for smoother peristaltic action and quicker transit times. Other amino acids like tryptophan and histidine, they act as really great, powerful neuroinhibitors. They stimulate the parasympathetic system to actually pump the blood to the intestines, and that stimulates the peristalsis. Remember, as tryptophan improves, your peristalsis improves. So does insulin improve. So insulin is a great driver for all of these amino acid use as well.
Can I ask a question about histidine? versus histamine or histamine. What's the conversion there? What's the issues with allergy? I remember seeing histidine in anti-allergic type formulations years ago. Not seen very commonly here, but it did seem to have a different effect. It seemed to work.
Yes, histidine is actually required to support digestive capacity, and histidine is the amino acid precursor of histamine, which is a neurotransmitter. Histidine is also involved in the production of glutamine as well, which is the most abundant amino acid. So histidine is triggered. The histamine is the neurotransmitter that's released from mast cells upon activation. So your T cells, your B cells are activated to release histamine from the mast cells upon an allergenic response. But histidine, its precursor, is involved in stimulation of neurotransmission pathways, but also involved in digestive capacity. It's also involved in asthmatic conditions. So using histidine can be very beneficial for allergic type reactions. And histamine, as you probably well know, can be up or down regulated by elevations of histamine is pretty common these days, and it's associated with a lot of neurological dysfunction ranging from depression to schizophrenia. And the two markers or two enzymatic functions, one is HNMT, which is histamine N-methyltransferase. It's a methylation pathway. So histamine needs to be methylated into its metabolites, or it could be driven by copper and vitamin C, which is through diamine oxidase. So if you've got a patient with a high level of histamine, it's really important to remove the histidine-containing foods and remove the histamine or stimulate the histamine metabolism as well.
I wanted to go back to the bodybuilding peptides as well. I mean, there was a huge rucka raised in Australia where, coaches were using unapproved polypeptides. I thought they were injecting them. Is that right?
That is correct, and peptides are available through compounding pharmacists as an injectable, yes. And so they have been used, there was obviously a role for a while ago, but that's been well regulated in Australia.
Right.
And now the action of these peptides have been, a lot of published work has been along the lines of stimulating that inflammatory or supporting the inflammatory cascade. So it's now the use of peptides in cancer, in inflammatory conditions, in autoimmune diseases has now been very well published and is used therapeutically in Australia today.
So we really need to upskill on that, because I was way behind the eight ball. I was still like, it's illegal, it's bad, and things like that. There are therapeutic roles and they work.
Absolutely. And yes, it is illegal for the bodybuilding practices. I think it's very, very well regulated in Australia, which is fortunate.
Yeah, I think for any sports people looking at this, they need to go to asada.gov.au and look at that. What about detox, though? That's a classic use in the naturopathic world. The orthodox medicos would say, that it's of no use whatsoever, and yet we see people getting better. But of course, there's these cautions. I remember a couple of patients were so sensitive, these chronic fatigue patients, and all they could take was glycine. How do you wend your way to find out which is the most appropriate, either single amino acid or combination of amino acids to help a patient?
Right. So when you're looking at a particular pathway, you can actually examine which pathway of the liver is not working effectively. Okay. There are many. There's phase 1 pathway, which is driven by cytochrome P450, and then the phase 2 pathways of sulfation, glucuronidation, glycination. So glucuronidation is really involved in your hormone metabolism, your amine metabolism, or xenobiotics are being cleared through these pathways. Your sulfation pathway is driven by the sulfur-containing amino acids like cystine, cysteine, etc., to produce glutathione. Okay, so when detoxification, patients who are super sensitive, they might not be, often you won't find patients taking amino acids on their own. They would take the amino acids in conjunction with possibly in a compound with herbs, liver detoxification herbs such as the Maristus or Bacterium or Dandelion, together with the various vitamins that will stimulate the utilization of those amino acids. So patients who are super sensitive, they might need to reduce their dosage to suit themselves, because the dose is quite variable. Of amino acids, and this is why it is great to look at the tables that are in the Alchemy of Amino Acids books to actually identify what dosing would be ideal for patients like that.
And obviously they can go from hundreds of milligrams to grams. Do you ever find super duper sensitive people where you've really got to be, let's say under the 100 milligrams, or is that just a drop in the ocean?
People like Ben Lynch, Amy Asco, these are our gurus in methylation. They talk about, Amy Asco actually refers to a dosing at a milligram level, much lower dosing.
Wow.
So again, it depends entirely on the constitution of the patient.
Yep.
But because proteins are part of our diet, they are an essential part of our diet, particularly our vegetarians, they would respond so well, the vegans would respond so well to amino acid supplementation. So dosing is important, but also amino acids do not appear in nature on its own. They appear synergistically with other amino acids. So therefore, it is ideal to actually look at a patient's amino acids through their testing and then supplement in accordance with their own levels as well.
Okay, so first thing there is when you talk about vegans, vegetarians, we've got to talk about the source of the amino acids. The assumption would be animal, but not so, correct?
Yes, the source of amino acids can vary significantly. Amino acids are now derived from fermented brown rice. They derive from pea protein, etc. Now, when you're having amino acids that are derived, individual amino acids that are compounded individually for a patient, these are often derived from a plant source, and they are synthesized in the laboratory to produce a USP or a BP grade raw material. Yeah.
Now, obviously, there's a lot more therapeutic applications covered in your book. Can we delve a little bit further into these?
Sure. I guess the easiest way to talk about some of these therapeutic applications, we know that neurotransmitters are produced, its precursors are amino acids. For example, tryptophan is activated at 5-hydroxytryptophan to produce serotonin, phenylalanine and tyrosine are needed to produce dopamine and adrenaline and so forth. But one of the areas that is worth making a mention of is the concept of glutamate and glutamine. Would you like us to discuss that a little bit, Andrew?
Yes, please.
Yeah. Look, glutamine is the most abundant amino acid in our diet, right? It tends to rise and fall with the changes in demand for glucose production, right? So when glucose elevation subsides, then glutamine surpasses all other amino acids, and it includes alanine. Alanine is a supplier of carbon for glucose synthesis. So glutamine actually contributes to the net gain of glucose for energy, right? Now, the way glutamine works, remember, is a precursor to glutamate. So glutamate is your excitatory neurotransmitter, which then eventually produces GABA, which is an inhibitory neurotransmitter. So glutamine does a number of things. Glutamine fluxes, it shifts between a number of avenues. One avenue is gluconeogenesis. This happens in the kidneys. Another avenue is glutamine is needed for glutathione synthesis. It's also needed for proline synthesis. So proline, ornithine are required for collagen synthesis. So in other words, that's involved in inflammatory responses. And then we've also got the GFAT, which is your glutamine fructose 6-phosphate aminotransferase pathway. So all of these pathways are involved in glutamine to glutamate production, and glutamate is actually formed by the transfer of the amino groups from your aspartate. It comes from aspartate, alanine, and other amino acids via your enzyme called aspartate transaminase. So all of your amino acids are either deaminated or transaminated to be inactivated or activated. And the idea behind this is to activate it to alpha-ketoglutarate. And we know that alpha-ketoglutarate is actually needed for energy production.
Yes.
So that's why we say that glutamate is actually a great brain regulator. It can be bad for you, it can be good for you. So what glutamate does, like at the presynaptic cleft of the neuron, the glutamine is converted to glutamate. Then it goes out and gets activated. It gets activated at these various receptors. The major receptor is NMDA, which most of us have heard of. That's your N-methyl-D aspartate. Can you see all of those amino acids? All your enzymes are actually amino acids.
Yeah.
The other receptor is AMPA, and the other one is Ka, which is kainate. These are the three receptors. Now, it's interesting. It's not only glutamate that is activated by NMDA, but D-serine and glycine is also activated by NMDA. Now, the body is so smart because it helps regulate. It's like a bit of a negative feedback system. If glutamate is too toxic to the body, then glutamate is reuptaken by the astrocytes. And ammonia, it triggers the release of ammonia from the bloodstream to convert to glutamine. So the blood ammonia uptake then stimulates the formation again of glutamine by the glutamine synthase pathways. And these wonderful transporters, all amino acids like progesterone and testosterone and estrogens are transported by your sex hormone binding globulin or albumin and all of those. These amino acids are transported by the FN1 and FN2 transporter systems. So they go ahead and transfer and transport that glutamine back into the presynaptic cleft. So to regulate that glutamate-glutamine imbalance. So essentially, glutamate and ammonia is involved. Ammonia from your bloodstream is recirculated to form more glutamine. So that's so amazing how the body is able to do this, because we know that glutamate is obviously your excitatory neurotransmitter. And it's involved, we also know that glutamate toxicity is associated with major neurological disorders, neurodegeneration, ALS, and in Huntington's, and all those sorts of conditions. Yeah. So it's really handy to know that we can up and down regulate these pathways efficiently in that regard. We know that there are drugs like glutamate blocking drugs, pharmaceutical drugs, which are basically NMDA blockers, and they're memantine, dextromethorphan, that sort of drugs. But then on a herbal perspective, we've got the likes of adenosine, which is really effective in helping to drive down excess glutamate as well.
Now, I didn't know that dextromethorphan was a glutamate blocker.
Yes, it is.
Yeah. I mean, this is a real... a call out for me, certainly, but for all our listeners, I think, to upskill about the pharmacological actions on amino acids. Are these covered in your book?
To a certain extent, some of them are covered in the book, yes.
Yeah.
There's not much information, so it's a matter of trying to figure out what is most relevant, because the idea is to really produce most practical and clinically relevant text, so that a practitioner can take that material and turn it into a tailored, compounded formulation, you know? So that's essentially what we're aiming at achieving there.
When we're talking about cognition support as well, and you're talking about, serotonin, for instance, I think it's interesting that the normal pharmacological avenue to treat serotonin issues is by using a selective serotonin reuptake inhibitor. But that really only looks at serotonin that is available in the synapse. It doesn't make any.
That's right. You're not topping up the tank.
So amino acids are used to prop up the tank.
That is correct, yes, as well as associated cofactors. And the cofactors are equally important because they are involved in the synthesis and the metabolism and the transamination and deamination of all your amino acids. For example, vitamin B6, tetrahydrobiopterin, folic acid, absolutely essential minerals and vitamins to work with your L-tryptophan to convert that into 5-hydroxytryptophan and serotonin subsequently. You
mentioned NMDA receptors previously, and the hyperexcitability of NMDA receptors can cause neurotoxicity, and it seems to be that magnesium is the magic mineral there to recharge the pump, to pump out the calcium influx, to dampen that stimulation. How useful and how relevant do you find either just magnesium, or do you use it with certain amino acids to help balance that production?
As I mentioned, amino acids are working really, really effectively with its appropriate cofactors. The cofactors, most often, when I prescribe and compound an amino acid formulation, I generally recommend a magnesium with a generalized B complex formulation to support the activity of your amino acids. So amino acids don't work independently, vitamins don't work independently, they need each other. So it's ideal to use the combination of both the vitamins and minerals together with the amino acids. Glycine and as well as magnesium would be probably top on the list to actually help block your NMDA.
And what about bone support? I was quite surprised to see that. I would never have thought of amino acid prescription for use with bone support. I would have thought about, more minerals. Tell us about that.
Okay, so bone function is essentially the use of calcium and magnesium, etc., and vitamin D and vitamin K and so forth. So you need any strategy to increase the bone absorption. Now, the amino acids, one of the amino acids, some of the amino acids are hydroxylated, and typically you will see certain amino acids in urine versus in blood, hydroxyproline, hydroxylysine. These are involved in connective tissue. Proline, ornithine, these are amino acids that are actually involved in production of collagen as well as connective tissue. So using a combination of something like proline, ornithine, lysine, and your branch chain amino acids like leucine, isoleucine, and valine, those are the three major branch chain amino acids, could be really effective in stimulating not only growth hormone but also bone production as well. So it's improving your bone calcification. Okay, so using something like amino acids together with a collagen formulation and calcium and magnesium would be an ideal blend to compound for somebody who has perhaps osteopenia or osteoporosis. Ornithine, tyrosine could be a really great example of a daytime blend for stimulating growth hormone. Whereas ornithine and tryptophan, because tryptophan is calming, it's an inhibitory neurotransmitter, could be useful together with proline to be a good nighttime blend, as an example. There are lots and lots of recipes that I can give you, but that's the sort of thing that you would want to look into. In terms of collagen, you want to stimulate the cross-linking of collagen. It's important to use ornithine, proline, and lysine. Those are the three major amino acids in conjunction with your minerals like calcium, magnesium, vitamin D, and collagen.
So it's not just taking the amino acid per se, but there's also a variation here, a temporal variation, a diurnal sort of variation, circadian.
If you are asking about amino acids that change through the circadian rhythm, I've had a look at some of the studies on it, and it's the only ones that are considered to be well researched are things like tryptophan, as well as histidine. There seems to be a diurnal pattern there. But the research is not conclusive.
Yeah.
And so I personally, because we're taking our foods 3 times a day and we're assuming we're taking some level of protein 3 times a day, I'm sure the amino acids would operate on based on a needs basis.
Yep.
But whether they're actually manufactured, synthesized, or metabolized in the diurnal pattern, I don't know that. I don't think that happens, but I'm not sure about it.
So celiac disease. Now, this one was interesting. This was it a high hydroxyproline?
Mm-hmm.
Tell us about that.
So, if we're seeing certain markers in your test results will reveal different, therapeutic roles in the body. We will find that elevations in hydroxyproline and hydroxylysine is associated with tissue catabolism. In your celiac patients, you will typically see they can be hallmark markers for celiac disease, elevations in hydroxyproline and hydroxylysine. So there are markers like hydroxyproline, particularly is a great hallmark for celiac disease. Hydroxyproline is also a marker of, cell turnover. So it's indicative of perhaps a leaky gut. Now, if you're looking at a patient who has maldigestion or dysbiosis or leaky gut, they would respond really well. You'll typically see elevations in hydroxyproline, but you will also find that patient respond well to leucine, isoleucine, valine. These are branched chain amino acids, as well as histidine to help with impaired protein digestion, as well as they will typically have a low level of tryptophan, phenylalanine, and tyrosine. Be aware, none of your amino acids will metabolize without a decent amount of hydrochloric acid, and as a result of taking huge amounts of PPIs, lots of patients on proton pump inhibitors, they may be having the ideal diet. Their body is not able to break down those proteins, and so that those amino acids become available to the body. So digestive capacity is so important.
Always.
It's really important to ensure that the digestive capacity is optimized so that the amino acids can be used. So we do find that elevations in hydroxyproline is considered to be a hallmark for your IBD type patients.
Right. So what about cardiac disease and, say, for instance, the use of arginine in production of nitric oxide? I've always been a little bit hesitant with arginine when it's not balanced with carnitine, but some people are quite happy to use arginine quite heavily. What's your view on this and how do you measure it?
Arginine is an interesting amino acid. It's so important. It's like the starting material from which it produces really diverse actions. One of the major actions is really production of nitric oxide, and we know that nitric oxide is required for cardiovascular dilation, blood supply, and so forth. Now, arginine is counted by a really great marker, which we call ADMA. Today, ADMA is actually measured. It stands for asymmetric dimethyl arginine. It is a marker of identification of, it acts as an inhibitor, endogenous inhibitor of angiogenesis. So arginine is a compound from which nitric oxide is formed, and ADMA, which is the marker that a doctor would measure, is the naturally occurring compound that actually does the opposite. It counters, that inhibits nitric oxide synthesis. So what ADMA does, typically if you see high levels of ADMA, then that patient is either undermethylated, purely because arginine is methylated to ADMA, and methylation is required for ADMA production, and ADMA then becomes the precursor to citrulline. Now let's just go backtracking, because it's important to understand what arginine actually does. Arginine has such major roles. Its transporters perform supply of amino acids to make proteins, right, for energy. Arginine is involved in urea formation to get rid of that excess ammonia. It's involved in the catabolism, so arginine is broken down to ornithine and proline for the production of amino acids, your collagen. Okay, so arginine is involved in collagen production in an indirect way. And then it's also involved in the synthesis of creatine, which is the substrate for energy storage in your muscles. And interestingly enough, it's involved in the upregulation of your polyamine formation in signaling mechanisms for apoptosis. So arginine would be an interesting contraindication where we're looking at arginine in various tumor growth. Right. You need to use arginine in with caution in patients who have or perhaps cancer patients. So arginine works amazingly well with ADMA. ADMA is your enzyme that you measure. High levels of ADMA is involved in nerve damage, it's involved in cardiovascular issues, and it's all because of the effect on nitric oxide. So L-arginine actually stimulates that nitric oxide synthesis, and it overcomes that inhibitory effect of ADMA, so they counter each other. So if a patient has high ADMA levels, we will know that that patient is likely to have a propensity towards arteriosclerosis, because ADMA inhibits nitric oxide synthesis. It inhibits the endothelial function, and that will then stimulate arteriosclerosis. So therefore, to drive down ADMA, we need to give the patient arginine. We need to use low-fat meals to help the synthesis and conversion of ADMA. Antioxidants are important. Vitamin B6, B12, folic acid, all reduces ADMA. So it's important to actually use, if you've got persistent ADMA elevation, they can be managed with drugs like your ACE inhibitors, for example, acetylcholinesterase inhibitors, and some of the natural estrogen replacement therapies. And exercise is one of the big ones that will drive down ADMA. So arginine you will often find arginine in a formulation for cardiovascular support with magnesium and taurine, and it works predominantly on the nitric oxide pathway.
Now, you and I have discussed the alchemy of the mind previously, and one of the topics that we spoke about was libido. How can amino acids help with libido?
One of the major amino acids is your arginine, because it stimulates nitric oxide pathway and it supports vasodilation. Now, I'm not sure if you've heard of various commercial formulations called, if I remember correctly, Dream Cream. It had some level of arginine to stimulate what we call the puffy lip syndrome. So that was, together with other dilators, that was a compound that was made. So arginine has a role there.
Was that the one where the catchphrase was "a little dabble, do ya"?
I think that's the one.
I think so, right, okay.
Yes, it creates the tingling feeling.
Yes.
Okay, so therefore, the sorts of amino acids that have been implicated in sex and libido, for orgasms, this is all work done by my peers, and so I can talk about some of these things based on their studies. Amino acids like histidine, arginine, lysine, these are amino acids that may be useful in supporting orgasms. To prevent premature ejaculation, one could use methionine together with your calcium and magnesium. To increase sperm count, one could use arginine and methionine. There's a number of these recipes out and about, which I'm happy to share, and it's all in the book. So sort of like a general formula for good sexual health might contain histidine, arginine, lysine, methionine, phenylalanine, tyrosine, and carnitine. Phenylalanine and tyrosine, the precursors of dopamine. And, that sex starts in the brain, not in the gonads. So, you need that motivation, and that's where phenylalanine and tyrosine comes in. Arginine is involved in your nitric oxide support. Methionine is involved in your methylation support. So there's a number of avenues by which these amino acids can actually support your sexual health.
Yeah, along with a candlelit dinner and some connection.
Absolutely, the chemistry. We definitely need the old chemistry.
Yep. With regards to amino acid testing, what sort of testing is available and what's the evidence to back that up?
So there are two major ways one can measure amino acids. One is a fasting blood, fasting plasma, and this can be done through a blood draw or blood spot. This is probably what we call the gold standard.
Yeah.
Because it has the greatest validation and has many scientific studies that provide generally higher level of reliability for showing chronic stresses that shift, based on the patient's amino acid demands. However, there's certain amino acids that cannot be measured in blood. They have to be measured in urine. And I find today the urine testing, I use a lot of that purely because it does not require blood draw and they are totally reliable. Now, urine testing is really identifying the metabolic disorders perhaps due to genetic polymorphisms or micronutrient deficiencies or even toxicant abnormalities. So amino acids, there are exceptions. For example, the taurine is a great exception. It generally tends to be higher in whole blood rather than in urine due to its concentrations it sort of hangs around in the erythrocytes. So as a result of that, you often find taurine high in blood rather than in urine.
Yep.
And then you've got your markers such as methyl histidine, 1,3-methyl histidine, hydroxyproline. These are, and beta-alanine. These are all markers that can only be measured in urine. They cannot be measured in blood.
Ah, okay. So the test that orthodoxy poo-poos is actually indicated at least in certain amino acids.
Most of the amino acids can be measured both in plasma and urine, but there are definitely exceptions. The urine can measure a lot more than in the blood, yes.
Yeah.
Hydroxylysine, hydroxyproline, example, they release from collagen of connective tissue and bone, and because they are released from the connective tissue and the bone, they are actually measured, cannot be measured in blood. They are measured in urine.
So to your book, Alchemy of Amino Acids, how's it set out and how's it designed to help practitioners institute amino acid prescription?
The Alchemy of Amino Acids was started or was formulated with the view of providing all the material a practitioner would need to understand the nuts and bolts of every amino acid. I must share this because the materia medica is the most boring part of the book. The book covers how to use your amino acids. What does it mean to have a low and high level of amino acids? What's the dosage? What's the therapeutic action of each of these amino acids? What are the side effects and contraindications of each of these amino acids? But this is all contained in a chapter called the Materia Medica. In my day, as a pharmacy student, we did a subject called pharmacognosy, and it's no longer done today. And we were blindfolded in this exam, and we needed to dip our fingers into various powders like Nux Vom or various herbal powders, and we used that, or even pharmaceuticals, and we identified the alkaloids and the terpenoids and the components thereof. And one of these amino acids that I remember really clearly is glycine because it's so lovely sweet. It's a really sweet amino acid. So this is a science that has been lost. But fortunately, we have all of this material documented. So the book, in actual fact, is aimed specifically at giving the practitioner or the reader all the information that they need, but most importantly, how to compound the various recipes, how to read a test result. Okay, it's very important to be able to see the patterns of the test results.
Absolutely.
And then once we've done that, how to compound an individual. So I have supplied the book is available as an ebook with lots and lots of tables, access to heaps of tables of easy to access tables so that you don't have to read the whole script in order to understand the value of each of the amino acids. And it is associated with, or it's matched up, linked with, about 20 plus hours of webinar material on Alchemy of Amino Acids. So we go and delve right deeper. If a practitioner is really keen to understand the amino acids, I'll give them the algorithms to be able to compound the amino acid formulation for the patient as well.
Brilliant. What about further learning? For those people that want to see what evidence there is out there, where did you learn this stuff from?
Oh, my peers are just amazing. There's some really, my gurus in amino acids are the works of Dr. Erdmann in his book called Amino Revolution, Dr. Braverman in his Healing Nutrients Within, Dr. Richard Lord and Dr. Braley, Alexandra Braley, in their book called Laboratory Evaluations in Integrative and Functional Medicine.
That's brilliant. I've got that one.
So these are they're my gurus, and if you really want to learn a lot more about it, these are the texts that you can go out and read up some more. The idea behind Alchemy of the Mind is grabbing all of that information from my gurus and putting it together in a clinically practical format so that the practitioner can take this material, look at a test result, understand which recipes would be best for which condition without testing, or with testing, how do I compound? What do I do to compound my formulation for the patient?
That's brilliant stuff. Vanita, thank you so much for taking us through. I mean, this is so in-depth. Obviously, there's a lot more, but if our listeners want to get in contact with Vanita, you can get in contact with her via vanitadahia.com. We'll certainly put these details up on the FX Medicine website for you to access, and certainly along with some of the research that we've spoken about today. Vanita, you're awesome. Thank you very much for talking about Alchemy of the Amino Acids today on FX Medicine.
Thank you, Andrew, and thanks so much for the opportunity.
This is FX Medicine. I'm Andrew Whitfield Cook. This podcast was brought to you by the book Alchemy of the Mind by Vanita Dahia.